using the expressions that we learned, the 3 dB frequency. Okay, and we discussed last time that what I do is I sort the poles and zeros. So I have pole 1, pole 2, 0, 1 in this order. They are 10 to the 4, 4 times 10 to the 4, and 10 to the 5 because I take the absolute value of omega z. هيدي صحيح عندها minus but it is 10 to the 5. Okay, from the dominant pole perspective, and this should be something very easy for you to know, first we check if the smallest of them is 4 times smaller than the next one. Does this condition hold here? Yes, 10 to the 4 is at least 4 times smaller than 4 10 to the 4. So I can use the dominant pole approximation and I can say that my omega h is approximately P1, meaning it is approximately 10 to the 4. And therefore I can approximate A of S to be of the expression هلا هون هو 1. What is the value magnitude of A of S at omega equals 0? If omega tends to 0, what is the low frequency gain? What is AM in this example? شو هي الS? الS is J omega, right? So if I write this as 1 minus J omega على 10 to the 5 over 1 plus J omega over 10 to the 4 into 1 plus J omega. صح. Okay. At omega 10 to 0 AM, it tends to AM, which happens to be equal to 1 in this example. Right? هلا بالكتاب يمكن الإكزامبل غير بالnotes, but I'm writing this example here to be this way. So we can approximate AS to be AM over 1 plus S over omega H. In this scenario, we can approximate it to be 1 over 1 plus S over 10 to the 4. Okay, this is the dominant pole approximation. The second method that we want to use it to approximate is the better approximation. And we saw last time that the better approximation has a formula, and I'm just grabbing this formula from the notes, and this formula comes out to be the summation of, I'm getting it 1 second, and this formula comes out to be a summation of the number of poles and the zeros. يعني the equation will be like this: omega h is approximately equal to 1 over the square root of 1 over 10 to the 4 square plus 1 over 4 times 10 to the 4 square. Okay, and this minus 2 times the square root 1 over the sum of the zeros square, اللي هي 10 to the 5 all square. Okay, and in this scenario, if we adopt this value, we will end up having the better approximation value to be WH will be around 9800 يعني والunit طبعا radians per second وهيدا الunit هو radians per second. So we notice that the value is shifting a little bit from the 10,000 that we got in the dominant pole approximation. Okay, so the third approach that we can use to estimate the 3 dB frequency is the exact approach. Okay, and in this we say that the magnitude of A of S at omega equal omega H is equal to the magnitude of the low frequency gain divided by root 2. يعني in this scenario, because AM is 1, it should be equal to 1 over root 2. طيب, what is the magnitude of this expression? I take the square root of each magnitude of each complex number, the numerator with denominator, and I take the ratios. So this means that I want to have 1 plus omega over 10 to the 5 all squared over the square root of 1 plus omega over 10 to the 4 all squared times the square root of 1 plus omega over 4 times 10 to the 4 all squared. هيدا this magnitude at replacing omega equal to omega h, I want it to be equal to 1 over root 2. Okay, now what we will end up doing, we will end up squaring both sides. Okay, so, and we will multiply, we will cross multiply, and we will multiply this by this and this by this, and I'm going to square both sides. And in the lecture notes, we have a reduced form, and this is written already, this is done. So we will end up with 2 into 1 plus omega over 10 to the 5 squared, and I plug in omega h here. I want it to be equal 1 plus omega over 10 to the 4, the all squared, into 1 plus omega over 4 times 10 to the 4 all squared. Okay, this is, I substitute omega h for omega. Okay, now this is a system of a polynomial. It's a polynomial equation in omega h, and I need to find its roots. To simplify things, we say let x equal to omega h squared. Okay, so we end up getting the following: 2 into 1 plus x over 10 to the 5 squared is equal to 1 plus x over 10 to the 4 squared into 1 plus x over 4 times 10 to the 4, sorry, هيدي squared بس below, and therefore accordingly we have, what is the degree in x in this example? شو البولينوميال degree بالx solution if we expand it? What is the power of x?
2.
Quadratic.
So I'm dealing with a quadratic polynomial. We know how to find its root, and once we find x, we use WH is what? It's the square root of x. So طبعا I need to take the positive root for x, right? So this is the exact solution. Okay, so for this problem, we end up having, if we solve for it, we end up finding that omega h is equal to 9573 radians per second. Okay, and we can see how the exact solution is 9573. The better approximation is close enough to it is 9800, and the dominant pole gave me an approximation, it is 10,000. Okay, so far it differed from 10,000 to 9573 radians per second. Okay, so these are the three methods if I have a transfer function which we use to find the 3 dB frequency, the approximate 3 dB frequency. Now, what we want to look into is that if we have a general expression for A of s, so for example, if we have A of s, let us say 3 minus, or 3 10 to the 5 minus s, okay, and over 5 10 to the 4 plus s into, let us say this is multiplied by 10 to the 3, and this is 1 plus s over 10 to the 6. What is the low frequency gain? How do you find the low frequency gain for such an expression? And what are the zeros and the poles? So how do I want to reduce my form always? I want to reduce it into the form of some am into 1 plus j omega over omega zi, okay, over 1 plus j omega over omega pi, right? So I want to make sure that those terms are 1 plus s over something or 1 minus s over something, 1 or plus or minus s over something. Do you know how to factor out things? So you should be able to know how to factor out things, am I correct? Tufi. Where is Tufi?
Yes.
Okay, so do you know how to handle such a problem? Okay, so you'll see similar problems to this in the midterms. Okay, so now the next step that we want to look into is if I take this expression, which is a of s equal to 1 minus s over 10 to the 5 over 1 plus s over 10 to the 4 into 1 plus s over 4 times 10 to the 4, and I want to draw the Bode plot for it. Okay, the first thing that I try to look at is what are my zeros and poles, and I take their absolute value. يعني هيدي 10 to the 5, here I have 10 to the 4, and here I have 4 times 10 to the 4. So if I want to draw the Bode plot, only for this time, I'm going to start from the initial expression, and later you can use this formula automatically. So 20 log magnitude of A of S is really going to be equal to 20 log, and all of this is base 10 of the square root of 1 plus omega over 10 to the 5 all squared minus 20 log base 10 of the square root of 1 plus omega over 10 to the 4 all squared, and minus also for the last term 20 log base 10 of the square root of 1 plus omega over 4 times 10 to the 4 all squared. Okay, so I have three terms here. Those three terms are A, B, C, and I'm really adding them up to obtain the magnitude of A of S at any frequency omega. So now if I want to draw the Bode plot, okay, if I want to draw the Bode plot, I'm going to start by drawing the location of the poles and zeros sorted in order in absolute value. So I have a pole at 10 to the 4, another pole at 4 10 to the 4, and I have a 0 at 10 to the 5. Okay, and this 0 at 10 to the 5 happens to be after the poles. طيب, what we're going to do, we're going to look here. So the green is the pole. So first I have a pole which happens to be at 10 to the 4. Great. So if I am going to see the first term, so this corresponds to the term B, right? And this corresponds to the term هيدي البول بتعطيني الترم C وهيدي البول بتعطيني الترم A. Okay, so let us see. So I have A, نحن حطيناهم بهالorder. It's okay. We had A, B, and C. But let me just reshuffle them. So I'm going to start with B first and then C second. Okay, and their addition gives me the response or the magnitude at any frequency. So if I look only at term B, يعني إذا بس I look at this term, we did an approximation when we studied the Bode plot. We said that this term is going to be 0 in the approximation before we hit the specific frequency here. And after this, all the way till the end, this term can be approximated by what? By minus 20 log of omega over 10 to the 4. Right? Anybody has any question? Now, if we look at the second term in yellow, that corresponds to the pole 4 10 to the 4. Come in, if we study it alone, which is term C, we have learned before that its contribution is 0 until I hit the pole, and after that it's going to contribute to the magnitude by minus 20 log of omega over 4 times 10 to the 4. Okay, over 4 times 10 to the 4. What about the 0? The 0 is the 10 to the 5. It corresponds to the term A, okay? And its value is going to be all the way 0, its contribution, until I hit the 0, and its contribution from there on is going to be 20 log of omega plus لأن 0 على 10 to the 5. Okay, so now really in any region, okay, I can take the contribution, the sum of the contributions of the 3, and I can find what the value of the Bode plot should be. But we are not going to do that. We are going to make it simpler. But first, let me look at those 3 regions. So here I had minus 20 log of omega over 10 to the 4 plus 0 plus 0. And here I had the same term, minus 20 log 10 of omega over 10 to the 4, but I added to it minus 20 log 10 of omega over 4 times 10 to the 4 plus 0. Here I had this term, and then plus 20 log of omega over 10 to the 5. Let's see what the coefficient of omega will be. يعني in this region, if I want to expand this, it will be minus 20 log of omega minus plus 20 log of 10 to the 4, right? So what is the coefficient of omega here? What is the log omega? إذا اعتبرت log omega هي x, okay, what am I multiplying my x with?
minus 20.
Minus 20, great. طب هلا if I carry this on to the next set of equations, and let us carry it on here. If I expand this form here, I will get minus 20 log, and this is for this part only, omega plus 20 log 10 to the 4 minus 20 log omega plus 20 log 4 times 10 to the 4 plus 0. إذا اعتبرت أنا الأوميجا هون هي x، أوكي، مثل ما اعتبرناها قبل log omega is x and log omega is x. What is the coefficient here? What is my coefficient here? Minus 40x plus something. Okay, so what do we notice? Every time a new contribution is being added, I am considering its slope. يعني the first pole entered, I added minus 20 times x. The second pole entered, صار عندي minus 40 times x. When the 0 enters, what will I have? In region 3, after the 0 enters, I will have my equation will become minus 20 log omega, صح? Plus some constant, minus 20 log omega plus some constant, and then from the 0, plus 20 log omega plus some constant. هيدول constants هون. Okay, so what is happening? Each pole, when it has an effect, will multiply log omega by minus 20, and each 0 will multiply log omega. لو كان 0 positive or negative, each 0 will multiply log omega by plus 20. So in region 3, log omega will be multiplied by minus 20 plus 20. شو بتصير هاي؟ minus 20 log omega. Okay? فإذا we will take a rule of thumb from here on. We will be using it. We will not do this derivation, but the basic idea is that I have to sort my poles and zeros, okay? And I will be able to figure the slope, Okay, so the gain in dB, okay, will be equal to some slope multiplied by log of omega plus some constant. We will not use the constant information because we will propagate it as we will see in the next example. Okay, but this slope is determined in every region by the number of preceding poles and zeros. Okay, يعني حسب قد ايه صار ماري, how many poles and zeros have happened so far, it is going to determine the slope for me. And pole gives me a slope of minus 20 dBs slope, and then the zero will give me a plus 20 dB, and I'm going to add the contributions accordingly as we will see in the example from the slides. Okay, let us now go back and see what the slides will show us, and we will follow up more thoroughly on an example. Okay. Okay, so let me share the screen and we will see how this example is being handled in the lecture notes. Sorry. Sorry, pardon. Okay, I apologize. هذا كل حقعته فيه. Okay, yeah. Let us come back here. Okay, so in the slides, here we are going back over the exact solution. We have the solution to the problem that I solved for you for the dominant pole, the better approximation, and the exact method. And we also have the example which we are looking at to draw the Bode plot for. Okay, so this is the final result. We will walk to it step by step, but first it is trying to show me where the exact 3 dB frequency appears with respect to the first pole, so it is close enough. And the slides are showing us if we were to draw the Bode plot, it will be in black, and the real transfer function will be the blue line. So first notice that the x-axis is a log scale, so I always deal with log of omega as my x, and on the y-axis I'm dealing with dB, which is 20 log of a. Because the low frequency gain is 1, this means at low frequency 20 log 1 is 0. Okay, so let's see how we construct a Bode plot. So here he's giving me the rules for constructing the Bode plot. He says sort the poles and zeros in order and put them on the omega axis. Then start with the dB value and slope at very low frequency. So start at very low frequency. The magnitude of the transfer function is equal to AM. So the starting value should be 20 log of AM. In our case, it is 1, so it's a 20 log 1, it is 0 dB. Then what happens is that, let us start with this and then we'll study the sentence before. The slope after a pole becomes the slope before the pole minus 20 dB. And if we encounter a 0, the slope after the 0 is the slope before plus 20 dBs per decade. So every time I hit a pole, I add minus 20 dB per decade to the slope before the pole, and every time I hit a 0, I add to the previous slope before the 0 plus 20 dB per decade, as we will see in the current example. This statement here, the statement here is above the encountering pole and 0 does not apply to our example, and it says that if we happen to start with an S, in this form. يعني إذا أنا my transfer function was s squared into 1 minus s over 10 to the 3 over 1 plus s over 10 to the 4, for example, times some other terms, then because I have only s, this means it's a 0 at 0, or if I had in the denominator s to the power something, either or, okay, then the total power of s, okay, times 20 dB is the starting slope. It's a very special case we will encounter towards the end of this part, or later an example that satisfies it. But let me, يعني إذا كان عندي s squared into something over something, I have two zeros, so the power of s is 2, and then the starting slope is 20 times 2. And if my example had over s squared, then really it is equal to s to the minus 2, okay? And so the power of s is minus 2, and I multiply 20 by minus 2, and the starting slope is minus 40 dBs per decade. This is what this example is supposed to tell us here, okay? So now what we care for this initial example, for you to get good practice, is we care for when I start with 20 log AM, and if I encounter a pole, I add to the slope minus 20, and if I encounter the 0, I add to the slope plus 20 dBs per decade. So let us look at the example, how it is drawn here. Initially, I plug in where my pole, the two poles and the zeros are. My starting gain is 20 log AM, which is 0 dBs in this example. Then, after this, he says I hit a pole, right? So when I hit the pole, when I hit the first pole, what was the slope here? And what should the slope be after? 0 plus
0,
what?
it should be minus 20.
So 0 minus 20 dBs per decade. Okay, great. So this is what this slide, second slide, is showing us. It's showing us that I hit a slope, and this slope is minus 20 dBs per decade, and the slope here was 0. Okay, now when I hit the second pole, so this is pole 1, this is pole 2, and this is the 0. When I hit the second pole, what should the slope become? I hit a pole, what do I add to the previous slope?
Minus 20.
Right, so this is minus 20 plus minus 20, this is minus 40 dBs per decade. Okay, so this is minus 40 dBs per decade. Okay, so then let us worry about the value later, but let us now, what would become the slope when we hit the 0? If the previous slope is minus 40, what is the slope here after I hit the 0?
minus 20.
Minus 40 plus 20 اللي هو بيصير minus 20 dBs per decade. Okay, so now I have the slope, and this will be the final slope. Now to determine this Bode plot, what more do I need to determine? I need to determine the value of these inflection points, right? What is the value of the gain here, and what is the value of the gain here, right? So to determine what is the value in dB at this point, and I know the slope before, okay, and I know this starting gain point is equal to 0. So since this scale is log of omega, and I know the slope, or I can say is that delta y over delta x equal to the slope. Delta y is gain 2 minus gain 1, so it is gain 2 minus 0. And delta x is what? Delta x is log of omega 2, which is 4 times 10 to the 4, minus log of, the omega 2 is here, So here I take log of omega 2 minus log of omega 1. What is omega 1? Tiny reference point. هيدي reference point 2. هيدي reference point 1. It is 10 to the 4. Okay. So if we want to find what is the gain at point 2, so if I want to label this as a G2 and this as a G1, this as omega 2 and this as omega 1, I have the slope minus 20 dBs per decade. We will say that delta y over delta x is equal to G2 minus G1 over log of omega 2 minus log of omega 1. And this is really G2 minus 0 dB over what is log of omega 2 minus log of omega 1? It is really log of omega 2 over omega 1. It is how many decades I have here, right? So this is equal to minus 20 dBs per decade. Omega 2 here 4 10 to the 4, omega 1 here 10 to the 4. I have this, I can solve for this. Anybody has any question? Okay, so let us look at the next slide. The next slide tells me the rule how to find it. It says the number of decades from omega 1 to omega 2 is really log base 10 of omega 2 over omega 1. And if at point omega 1, the gain is G1, and at point omega 2, the gain is G2, and I know the slope. Okay, if the slope is A, then I can find that G2 is going to be G1 plus A times log of omega 2 over omega 1. So at any 2 points, if I have the gain at one of them and I know the slope in that zone, I can figure out what is the gain at my new frequency. And in this equation, you should remember it very well. Okay, so this is a very important equation. Okay. Okay. So using this, we can really go back to the previous graph and populate the values at each inflection point, and we can find the slope and the dB at the different points. Okay. Anybody has any question here? Is this clear? The slope and how to find them in each region?
Yes.
Professor,
Yes.
before you mentioned that if the difference between poles is less than, I think, 4 times, we can neglect the one that's directly after it. In this case, can we neglect
No, we do not neglect. What we said, that was in the, let me just go back to where we mentioned this. We said that if we want, okay, there are 2 things that we were talking about here, right? First, if I have an expression and I want to approximate my transfer function into a simple form that is written like this, I need to find omega h, and to find what omega h is, if مثلا مثل الإكزامبل اللي عنا إياه, we have 10 to the 4, okay, is less than 4 times 10 to the 4 and the other zeros, then I can assume that omega h is approximately 10 to the 4, and I can use the simplified form. So if we ask you what is the dominant pole, okay, or find a method the best using the dominant pole method, or using what is the 3 dB frequency, إذا عم نسألك. And if the dominant pole, using the dominant pole approximation, if this holds, then we can assume that the first one is the dominant pole, can be assumed to approximate the 3 dB frequency. If they are closer to each other, then I cannot use the dominant pole. يعني لو كانوا البولز pole 1 هي مثلا 10 to the 4, pole 2 هي 2 times 10 to the 4, I definitely cannot use the dominant pole لأنه منن أصغر, it's not smaller by 4 times. And if I had a 0 which is at 10 to the 5, then I need to use the better approximation to find the 3 dB frequency of the system approximately where it should be. Okay, so if we ask you a question, find the 3 dB frequency using the better approximation, or find the 3 dB frequency using the dominant pole, or can I use the dominant pole to find it? You will be able to decide on that. Then the exact approach or the exact solution gives me the exact value for the 3 dB frequency. And you can directly plug into this form. يعني عندك P1 P2 ما عندنا غيرهم، عندنا omega Z1 ما عندنا غيرهم. This is the equation. We plug the values for omega P1, omega P2 and omega Z1 and we find X. X will tell me what omega H, what the 3 dB, the exact solution for the 3 dB frequency is. Okay, so this tells me what the exact solution for the 3 dB frequency. Okay, this is different from when we are trying to draw the Bode plot. Okay, let us see what did he show here in the drawing of the Bode plot. For the Bode plot, irrespective if my omega 1, how far it is from omega 2 and the 0, I would still draw the Bode plot. Yani, if he tells me that it is 1 over 1 plus s over 10 to the 4 to the power 2, what do I do with this? I have two poles in the same location. What will happen here? I ignore one of them? No. I will have a response.
By 40.
صح? And that will go down as a slope of minus 40, right? So the 3 dB frequency, the exact one happens to be here. And I know if I operate before it, my gain will be almost very close or reasonably good. Okay, so the two things are different. Do not ignore anything in the Bode plot, okay? Okay. Anybody else? Thank you. Anybody has any other question? Time great. Okay. So the short quiz for Monday will be including the dominant pole, يعني the 3 dB approximations, and the Bode plot magnitude mainly. For the phase, we will have to maybe I will try to point you يعني to a couple of practice problems لأنه it's a little bit more complex than here. Okay. طيب هلا, but for the phase, let me ask you a couple of questions. For this example here, do you know how to find what is the phase of the system at infinity? يعني as omega tends to infinity, what is the phase of the system?
We ignore the ones because S is much bigger than 1 and we
اوكي خلينا نرجع نراجع one pole كانت distribution لها هيك بالmagnitude and its phase at infinity it starts from 0 and then it drops minus 45 degrees and at infinity what does it become? شو ال contribution للpole?
minus 90.
Minus 90 degrees. So each pole, each individual pole will contribute to minus 90 degrees. What about the zero? يعني أنا إذا عندي term, if I have a term, which is 1 minus j omega over 10 to the 5. What is the angle of this term?
Minus arctangent of arctangent. Yeah, minus arctangent.
Okay, as omega tends to infinity, what does this tend to?
Minus 90.
Okay, so إذا كان negative 0, a negative 0 at infinity will contribute to minus 90 degrees. A positive 0 at infinity will contribute to plus 90 degrees. And a pole will contribute to what? Pole has to be positive, but it is going to contribute to minus 90 degrees. So this is very important for you to remember. يعني at omega equal infinity, this circuit شو حيكون الفيز لإله؟ I have a negative 0, so حيعطيني minus 90 and I have 2 poles رح يعطوني 2 times minus 90, so this will be minus 270 degrees. Okay, so this information I expect that you should try to remember. Okay, كل pole على infinity يعني towards the end حتعطيني minus 90 and every zero will give me إذا كان positive بيعطيني minus 90 وإذا كان negative بيعطيني sorry إذا كان positive بيعطيني plus 90 and إذا كان negative بيعطيني minus 90. Okay. طيب. Anybody else has any questions?
Yeah, you said إنه البول إذا كان positive بيعطينا plus 90 إذا negative بيعطينا minus 90.
لا الزيرو
yeah.
إذا
البول
positive أو negative البول على طول تعطيني minus 90. the zero إذا كان positive بيعطيني على infinity plus 90 وإذا كان negative minus 90 by virtue of basic complex numbers, right? The angle is the sum of those angles وكل وحدة عندها الارctangent لإلها وحنجمعهم we're gonna add them, right? Okay?
Yeah, all right.
Okay, there's a sheet on Moodle that explains the phase